Hello and welcome to this course on an introduction to blueprints for the Unreal Game Fellowship for 2024. I am an instructor here. My name is Edward Bennett. So let's talk about the objectives for this course. Firstly, this is supposed to be a first touch into using blueprints within Unreal Engines. We would like to familiarize you with the basic concepts of object-oriented programming and give you an understanding of where blueprints and what their role is within the engine. We'd also like to create create a blueprint from scratch so that we can actively put into action a number of the underlying principles to using this. And we're going to look at a lot of getting actors to communicate with each other. So we're going to talk about different ways of taking an actor, which is anything that we've placed within our world, and getting it to talk with other actors, which is quite a fundamental underlying sort of skill you need to understand for working within Unreal Engine. So let's talk concepts. Now, to start off with, if you are following along with this course, we are going to be working with a basic first-person view template inside Unreal Engine under the game's templates, and we'll be using the starter content. So if you follow along, when you create it, please tick the box to include starter content. So let's talk about some concepts. What are blueprints? Now, blueprints in Unreal Engine is our visual scripting language that allows you to create game logic without writing any code. So they're essentially flowcharts where we will connect nodes to perform tasks, handle events, and manipulate data. This makes it accessible for developers and designers alike who may not be well versed in programming languages such as C++. So I think the history makes this easiest to understand. But when Unreal Engine first started out, you would have quite a divide in the people who worked in the engine. You would have a lot of people who were the sort of heavy coders, and then on the other side you'd have the inverted commas creative types who would do a lot of the level design, or they would sort of create the characters or the materials and sort of and not often did the two skills were quite unique skills which were quite distant apart. Now, this is where blueprints comes in. What blueprints originally did was took small fractions of code and provided a visual interface that level designers and the more creative types could find easier to understand, which would allow them to bolt together some functionality. Now, this started out like that. However, it has grown massively in its years, along with the engine as it's got better. And now blueprints are a very acceptable way of generally coding. A lot of people use it for prototypes, but it's often used within the engine to complement C++. With a lot of games having some element of both C++ and blueprints custom code inside them. Now, there are even some games which are almost completely made in blueprints that have been published. I'm sure there is a lot out there, but there are some quite borderline sort of double A, at least, if not triple A games, which use it. Now, it is speed is a arguable thing within blueprints. Now, the blueprints code are actually accessing C++ code. So it has, once it's compiled and packaged, in theory, it runs as fast as C++. However, there are some reasons why it wouldn't run as fast. Firstly, there is an overhead where we go away and call the code. Secondly, it doesn't offer the same level of sort of optimization that you would get from straight C++. There is a lot of sort of like checks and balances, and sometimes the code is written so that it will work in multiple circumstances and check for a bunch of things, where you might be able to not include that code if you were working in C++. So functionally, it's still very fast, and if it's not, and if it's written in a relatively sensible way, you shouldn't notice the slow speed of it, where you'd probably find bottlenecks elsewhere in the engine, such as part of the graphics card and the graphics handling. So we're going to be touching on a number of different concepts that are part of object-oriented programming. And the first one that I think is really useful is to understand the difference between a class and an instance. Now, I think it's easiest shown if you look here in the image. The class is going to be, well, a class serves as a template for something that you want to create that can be, and it's seen usually within the content, seen usually within the content browser here. So you can see here we have the third person character, and an instance is what you get when you drag the class into the world. Each instance can have its own separate settings, even though it originates from the same class. So you can see here that we have the class for the third person character, and we have 3 instances that exist within the world. So as soon as you drag a class into the world, it will create an instance of that class. So that's classes and instances. The next concept is going to be inheritance. Now, I'm going to jump into the engine a little bit because I think this is easiest to see within the engine. Now, I have my first person template here. And again, I'm going to bring my content drawer up, lock that in, dock that in the layout. And just hide my taskbar. Okay, so let's talk about inheritance. Now, if I was to, we're very often, I'm going to ask you to create a new blueprint. And we would do that by right-hand clicking and select Blueprint Class. And I think this is the place where it's most clear for us to see how inheritance functions. Now, it's interesting when you create a class because every class within the game engine would have a parent class. Now, if we open this up, we've got an option of some common classes at the top here. But almost if I was to hide that, what we've got is a list of every single class within the engine here, all under different categories. Now, classes are very important because they are where all the different pieces of code is and where the data is going to be saved. Now, you can see here that we have a actor class. No, well, we've got an object class. And if I bring this back, object class, if you are working within C++, this will be UObject. This is the highest class that we have available within the editor. This is, now, the object class has a bunch of functionality that is connected to it. And we'll go into it. Actually, I think the next one. Okay, so the object class, this is the highest class that we'll be working with within the engine. And you within the editor, you can't access any other class that isn't a child of this, I believe. And so the object-based class, now this has some functionality into it. Now, you won't be aware of this functionality because it is just functionality that allows it to function with Unreal Engine correctly. So it's stuff like garbage collection, which is about how the memory is cleared up when you've stopped using something, how unused memory is reallocated. And now, so this is our top class, and anything that you work with inside of the engine will be a child of the object class. Now, below that, we have the actor class. So the actor class inherits from its parent class. So an actor class will get all the functionality from the object class, but it will also add on some extra functionality within it, or override some functionality from above it. And the actor class, all it has is the ability to be spawned into the world, complete with a transform for position. So this means an actor can exist within our levels. It will have something that's referred to as a transform. Now, that means it will have a location, rotation, and scale. So this is complicated functionality, which is just part of the actor class. And whenever you create a class from the child of actor, it will have all of the functionality for being placed within the world. And now the actor class has a pawn class that is below it. And a pawn class inherits everything from the actor and everything from the object. And in this case, it will also have added functionality that it is capable of being possessed, as in to receive input from a controller or an AI controller. So a pawn is going to be something that we will be able to move around, or we'll be able to possess as play. Your standard character or something will be a child of the pawn class. Now, below that, we have the character class. Now, the character class is interesting because it has a number of preset and components in it. For example, it'll have a skeletal mesh, and that's what's going to show the character as it moves around. And it'll have a movement component. And a movement component has all the functionality that's needed in order to run, jump, and move about around the world. And this means, and this is all pre-written code that allows you to very easily come into the system and make a new character. All you need to do is come in, change the skeletal mesh, and you alter the keys, and you've got a new character that can already run around, already can be possessed, and already can exist within the world, and already has all of the garbage collection and everything sorted. So the main points that I want you to take away from this is that everything is a child of the object. All of the classes have a parent class, which they will inherit functionality from, and functionality can be overridden. But what class you are and what class you're talking to is very important. And also, say that we have a character class, it is also an actor, and we can talk to it as if it is an actor. So we can do something that's called a cast to. So we can talk to the class of an actor, but if we are talking to it as the class of the actor, we will not have access to the movement component or the skeletal mesh, because we are not talking to it as the correct class. But it is an actor class. It's just we need to talk to it as a character. And this is going to become important because we're going to be looking for levels of functionality. And the levels of functionality you'll be able to get out of an actor is not the same functionality you'll be able to get out of a character. So it is important what class we are talking to at any point. So let's look at that in Engine. Now, we can see here, this is giving us a list of every single class that already exists and is available within this engine. Now, what's interesting is we've got a load that are not children of actor, and because they're not a child of the actor class, they aren't something that would exist within the world outliner. They're not something that would exist within the world. However, if we were to do a drop down of the actor class, you can see a whole load of different classes, a lot that you haven't seen before, but all of these are children of the actor class. So all of these can exist within the level. There's lights, there's volumes, there's meshes, there's a whole load of different stuff. Paper sprites, a ton of different things. So now if I search beneath these, so as to search for character, you can see here we have the inheritance chain that we're looking at. We have the object, we have the actor, and an actor is an object that can be placed or spawned in world. Pawn is an actor that can be possessed and receive input from a controller. And character. A character is a type of pawn that includes the ability to walk around. And you can see that there are even more here, like first-person character. The character you control in games includes a firing logic. So this is I think this is an important view because you can see all of the different elements. We've also got actor component here. And this is a good way to view the inheritance. So rotation, rotate, movement. What was the rotation movement? Let's see if we can find that. Sorry, add rotating movement. Oh, I can't find that. Anyway, so let's jump on to the next slide. You can also have multiple child classes. So you can see in this place, we are looking at different components. So we're looking at an object which could have numerous different child components. And then from the actor, you can have numerous different child components that exist under them, all the way down to sort of different elements. Now, all of these are children of an actor and therefore will inherit the functionality of an actor, and so on. So it allows us to sort of modularize where we put our code so that we can, and functionality, because there's a lot to be said for making sure you've got the correct functionality in the correct place. Not all of them need to be actors. We can have components which are like the rotating movement component or a static mesh component. There are things that are added to an actor which do something. We're gonna work with a number of those as we go. Okay, so I always think of this as a kind of like a sort of car analogy. So you've got like a vehicle, and then below a vehicle you could have truck or car. And then below car, you could have sports car or all-terrain. Under all-terrain, you could have the brands of the car. And so all of them are going to have different settings, like a sort of speed, paint job, sort of different elements. Okay. Interface. Okay, let's jump into the engine at this point. Let's start creating stuff. So let's create a blueprint class. So if once you're into the engine here, I'm just going to go in the content directory, I'm just going to right-hand click and I'm going to create a blueprint class. Now, at the top, you can see we have some common classes. So we've got the pawn, the character, the player controller, a number of the other ones. We're just going to start with the actor. Now, as we mentioned, the actor, this is something that can be created into the world. So I'm going to call this example. And whilst it's here, it is just a class. As soon as I drag this into the world, that is an instance of the class, and I can drag in, I can focus on that, and I can create multiple ones. But the only thing we can see at the moment is the billboard. But let's open up our example and jump into the example we have here. Okay, so hopefully you've got something which looks a little bit like this. So let's go over the different sets of the interface that we've got here. First thing, again, at the top, we have the menus. There's nothing particularly unique I want to go over on here, so I'll leave that as it is. And then we have the toolbar. Now, the toolbar does have a couple of unique things. So the first thing is we've got save. You'll find this commonly across most other windows for assets. If you push save, you can see the little star goes away and it is saved to the disk. Now, next up, we have this browse. And this is useful because what this is going to allow you to do is, say you're off in a weird directory here looking at this texture, and you're like, oh, I want to put this into the world so that I can test it out. Well, you need to then navigate and find it in here, which can be a bit painful because if you don't know exactly where it is, you might have to spend some time trying to find it. However, if you push the Browse To button, it will change the content browser and move you directly to the asset that you've created. So that is the Browse To button. And you'll see this across lots of other parts of the image. Next up, we have the Compile button. This has three states. It has green, that means it is compiled and it is good to go. I'm just going to break something quickly so that we can I think, no, that's not good. No, I've got to find something that won't work out of the I know, player controller. Sorry, I'm just trying to find some way to break it quickly. Yes, okay, there you go. So we have we have a couple of options. So the first one, green is compiled, and that means that this will run. Red means that there is an error during compilation, which can be found in the compiler results. So in this, I just haven't connected this up correctly. But don't worry about that too much. If I delete that, you'll see it's yellow, which means it's dirty and needs to be recompiled. So that's the compile button. So just be aware that if it's red, it means we've got some kind of error. Next up, we have diff. This is about source control, but revision control. We don't have revision control turned on, and we're not using it in this project. So I will skip that. Find is going to allow us to search for pieces of code, and then below that, we're going to be able to jump to it quite quickly. So find very useful. Hide unrelated. I'll demonstrate that later on, but all it does, well, I'll demonstrate it in a minute. So if I've got a bunch of code here, if I have hide unrelated clicked on, you'll see that whatever code that you are connected to, everything that is connected to that will be in full color. And if everything else will be grayed out. So you can see this is grayed out. Now, next up, we have the class settings and the class defaults. Now, these are going to be ways of getting and editing data that is from the parent class. So we'll be looking at different settings that we'll be able to set. There's a number of things such as how we work with tick and other lots and lots of just general settings, but it will have the parent class settings in here. As you can see here, we can see in the top right hand corner, my parent class is actor. And it's quite easy to reclass them. Second one, you've got simulation and play. These are allowing us to, these are just shortcuts really to either simulate the game, see what happens, or to play the game. Now, one of the things that is worth noting is I'm just adding some delays in here. If I've got this box here, and this is the debug box. And this means whichever instance is selected is going to be the instance where they play back the code that runs. So if I was to hit play now, if I was to hit simulate, what I want to do is I'm going to play, get rid of that. You can see the code going here. Sort of action. I'll make the delay longer. Run. So with whatever version of the instance, this is all the instance. I've got 3 instances in the level. It will play back the code for that instance. So you can watch the code run as it goes. Okay, so that's the toolbar. Now we'll get more used to this as we understand the rest of this. But now, next up, we have the components panel. Now, the components panel are I think the easiest way to understand components is they are just like the things that are in the world outliner here. So you could consider all of the actors are effectively components of the map. And so what this means is these are all things that do stuff and exist, and you can access them, where this is the equivalent. So say I wanted to add in a cube. I could come in here and I could just add in a cube. Now, and this is visible. Now, the interesting thing about the cube is it's not actually a cube, this. As you can see, it's just renamed to cube. It's actually a static mesh component. And if I was to add in a sphere, you would see that the cube and the sphere are almost identical because both of them are static mesh components. And the cube itself, I could easily just come into the sphere, change it to a cube. And it's the wrong type of cube, but you get the idea. And it would change the mesh. So the name is just set out. So these are static mesh components. I'm going to delete my sphere and just leave my cube here. Now, there are numerous different components which I can access from here. So I could come in here and stuff like, I'll do a cascade particle system because I know we've got some smoke in here somewhere. Fire. So just by adding a component for a cascade particle system, we now have a cube which is on fire. And not all of the components need to be visual. For example, the rotating movement is one which I've demonstrated earlier, which just spins the cube in space. Like that. I'll stop simulating. So the functionality of what you do, it can be a lot caused by what is in the component panel. The other element is, as you notice here, if I get the cube, we'll talk about the viewport a bit in a minute. But as I move the cube around, the fire moves with it. Now that's because the particle system is actually parented to the cube. If I parent it back to the scene root by dragging it and attaching it, I'll now find that that moves sort of accordingly. Okay, so I'll just jump back to the level map. God, it's such a... one of the things you might have noticed is now all three of these have changed. And that's because I have updated, because these are instances of this example. And if I push play, we can see that they're all spinning and they're all looking good. Okay, so that's three instances of the same blueprint. Okay, so we've gone over that. Now, my blueprint's on the left-hand side here. Now we're gonna go and practice. We're gonna jump into a what's the name in a minute, but if you do come from a coding background, you'll probably notice this is a bit like the header file, where you need to sort of declare stuff. We have the event graph, which is make more sense in coding. We have functions and we have variables, which all can be declared. But we'll go into much more detail on these. On the right-hand side, we have the details panel, as per usual. And again, as you select different elements, the details, this is contextual. So depending on what you have selected at any one time, the details panel is going to update accordingly. Okay, so in the center here, we have our viewport. Now, you can navigate this pretty much in the same way as you can the level. A lot of the functionality is still there, maybe some stuff missing, but you can change the rotation, the scale, and the location. Bear in mind with this that it is all, we're looking at relative, we're looking at relative locations. So they are relative to their parent. So for example, if I was to grab another, let's grab a cone. Now, I'll get my cone up here. Now, because the cone is a child of the cube, as I change the scale, for example, of the cube, the scale of its children are going to be changed as well. And that's because they are relative. So the actual scale of the thing is still default, but the parent is skewed, so it looks skewed as well. So yeah, and so be aware that this is relative. Okay, let's jump into the actual coding part of it. So if I jump over here, this is what's called our event graph. And you can see that we have two tabs, our event graph and our construction script. Now, the only thing that you have to start with is a couple of grayed out, well, you should have 3 grayed out sections at this point and a begin play. Now, with the begin play, I'm going to put some code onto this. There are 3 methods of getting code into the engine. And so the code are these nodes. They are built to do something. Now, I'm going to do it in order. Actually, I'm going to just do the 2 main ways of getting code into this. So the one way is there's hotkeys. Now, there's only a few hotkeys that I regularly use, but one of them is B. So if you hold down B and left click, it will create something that's called a branch. Now, if you're used to programming, this is the equivalent of an if statement. We have a condition, and based on if the condition is true or false, we will go down different execution pins. So branch is one. We also have S gives us a sequence. O gives us a do once. And there isn't many more. Now, this isn't so useful. Branches and sequences, some of them are okay, but hotkeys are really useful when you're making materials, because in materials, you tend to use a few amount of nodes a lot, where when you are coding with blueprints, you'll tend to be using a lot of too many different nodes to effectively have them on hotkeys within the engine. So branch and sequence are probably the only 2 I think are worth memorizing at this point. There are, D for delay is quite good as well. I use that a lot. This will just stop and wait for 0.2 of a second. So you can try that out, and that will give you a couple of different nodes. But the most common way, and actually, talk about navigation quickly because I kind of forgot that. If you want to move around the blueprints, the first thing is if you right-hand click on the background, you're going to be able to drag the background. Now, the next thing is if you scroll in and scroll out, you're going to be able to zoom in and zoom out. And if you're not able to zoom in far enough, you hold down Control, you can zoom in even further. Okay. So zoom in and zoom out is the middle mouse wheel. Right-hand click and drag is going to allow you to move around. Okay, so next up, we have connecting up things. So I've got a sequence here and a branch. If I wanted to connect this up, I'm going to drag off begin play. And so I left click on the pin that I want to drag out. So this is the execution pin. Drag off, and I can plug it in. So you can see there's a small green arrow if I go over a pin which will accept it. So that is how we connect up the branch. Now I can connect up a second branch there and it will disconnect. The other element I can do is if you want to get rid of one of these lines, and hold down the Alt button and left click, and that will delete a line. Now, if you want to move a line from here to below, if you cycle over and press Control, it'll give you a little hand, and you can drag that down. So Control gives you a little hand, and you can move where it's plugged in. When you hover over any of these buttons, you'll get this sort of arrow in 4 directions. Left click, and that's going to allow you to move anything. I think there's a H. Maybe it's Q. Yeah. Another thing is if you want to straighten lines up, if you select all the bits you want to straighten, push Q, it'll get it on the same vertical line. So you might find that useful. So again, and this is a real basic foundation, if you want to grab, you just grab on something like that. If you want to move, you grab on the background with the right-hand mouse button clicked. To disconnect, press Alt to move a connection, hold down Control and drag it out. And yeah, I think that's pretty much most of it. Now, this works for any pins. Now, one of the things I would note from this is you can see whenever we're looking at one of these, anything that's on the left is inputs and anything that's on the right is outputs. This is something that has 2 execution pins. It means this is part of a macro of a flow control that is allowing to control how you go forward. Okay, so let's talk about the real way of adding nodes. You've got the hotkeys. But the most commonly used way to add nodes to it is right-hand click will bring up a search box. And a search box is awesome because you can search for anything. And it's quite a sensible search. So if I was to search for if, for example, it would bring up branch. Then if I press enter, we would create our branch. But if I was to search for print, for example, we're going to use print strings a little bit. You get a different function. Now, this, and we're going to talk about this a bit further in, but you'll see that there is a box in the top right-hand corner of when I'm searching for nodes, and this says context sensitive. Now, when I unclick that, you're going to see that this gets a bit smaller. It's not, it will seem more apparent in other instances. But what this means is if you were going to create this node here, it's going to filter out only the nodes which would make sense for it to exist here. Now, this means that a lot of the code that you're looking for might disappear. And if you want to see everything, just untick the context sensitive, and that's going to give you a ton more options. But it won't necessarily mean you might have trouble using that code. For example, we have blend viewport, blend view with target. Okay, so for this, for example, this is going to request a target. And if I was to put context sensitive and search for set view blend, it's not going to appear. That's because this node is not part of the actor class. It is part of the player controller class. So I'd need to, and that if I plug that directly in, that's going to error. And that's going to error because this is not a node which exists within the class of actor. This is a node which is part of the player controller. So to get this to work, I'm looking at the target here. You can see get player controller. So if I can just type in get player controller, and I can plug that in. I think it's still going to complain. Oh, it's not. There you go. However, with this contextually sensitive, if I wanted to know what I could do from the player controller, I could just drag off there. And now you'll see that this is context sensitive to anything that would plug in to the player controller. So now it is only showing me the code which is connected to the player controller. And this is why knowing your classes is important. And all of the next lesson is a lot of it's going to be about that. Because if you are looking for code, you might not be able to find it within, you might not be able to find it directly within the code. So here, I could do blend set view 10 with blend. So that's a piece of code. However, say I wanted to go backwards from that, and I knew I needed this node, but I didn't know what it connected to. I could always type set view target, turn off context sensitivity. Now, because I've turned that off, I can now see the node. Then once I've created the target, I can hover over it and it will say a player controller object reference. So I know that that needs to be connected to a player controller object. Okay, that might be a bit advanced. We're gonna do a lot of this, but the first hour is going through everything. Then we've got an hour of example. And I'd like to give you a 5-minute break. Okay, so we've created nodes. Let's look at these. These are events. These red things that we got here are events. If you drag off this event, type in print string, you can see here I have a very simple node. It just says hello. It will print hello to the screen. So now, if I come into this level and I push play, you can see there are 3 hellos in the top left-hand corner. Now, I can actually extend the amount of time this hangs around for, so we can see this a bit better. So I'll make it 6 seconds. I'll also make the color black so it's easy to see. So you can see what I'm doing here is I'm just changing the input settings so that it does what I want it to do. It's hanging around for longer. The text color is black. And I can also change that to event fired. Make it fired so that we can see. So the input pins on the left are manually changing so that this does something different. Now, if I jump back in, see it says event fired 3 times. So that is begin play. So if you had code you wanted to run and this will trigger when the game starts or when the actor is created into the world, spawned into the world. But let's move this print string and let's connect it to tick. I'm just going to disconnect it from here. So I'm going to compile. I'm now going to play again. And you can see that we have event firing all the way down the left-hand side here. Now that is because tick runs on, by default, runs on every frame of a game. So any code that you add into this, if your game is running at 60 frames per second, any code you've added to this will be run 60 times a second. Now, so you need to be aware. It's great for like updating animations or doing a bunch of different things, but it can be quite intense. Now, there are some ways you can do some stuff like you can turn off tick, or you can set the interval, or a whole bunch of other stuff that you can do with it. But just bear in mind that runs every frame. So be careful what you do with it. Now, here's another thing as well. If I come here and I press Control Copy, I was going to copy this to the clipboard. Now I can press Paste and paste them in anywhere I want. I can do that with multiple ones, or I can press Control X and Control Paste, and I can even duplicate with Control D. Next up, let's have a quick look at the construction script. So if I plug in our event fired into the construction script, delete them on here, press compile. Now, what's interesting is construction script runs on the point of construction. So whenever you place or move it around, just need to show, can you see that it would fire on every single frame as you move this around? So it disappears, and then as I move it, it fires. And this is great if you need to do any code at the point of you're setting up your assets. So some smart objects like query the world around them so that they can like set themselves up accordingly. Okay, so that is the event graph, the construction scripts, and we've got the view. Now, next up, we are going to put all this into action and talk through it. So, are there any questions I should address before we take a quick break, guys, or is it all look good? Hello. So, let's kick off with, let's clean up a little bit and we will get going with the example. And hopefully we'll be able to put a lot of the kind of stuff we've been looking at in a bit more context as we're going along. So the first thing I'm going to do, hopefully you've all got this project open, is I'm going to delete what we've been working on. So I'm going to get rid of my gun as well. I'm also going to delete my example, just so I've got a nice clean project again. So we've got a new project. Right. So we're going to create a door. I'm going to make a door that can open, close, and be locked. So to start off with, if we right-hand click, you'll see that under Blueprint Classes here, I'd like you to come up to Blueprint Classes so that we can create a new one. Lucas and Andrew, do you tell me if I'm going too fast or slow, or people are having trouble and they want me to go back and show stuff? Because I'm worried about losing people as we go along. It's okay. So I'm going to start from an actor base. So we're going, again, we talked about this. This is just a class which we're capable of, it's capable of existing within the world. Okay, so we have an actor, and I'm going to call this BP underscore door. So this is going to be our door actor. And if we double click to open it up, I'm going to dock it at the top here so that we can see what I'm doing. Now, I want to have a couple of different components as part of my door actor. To start off with, we're going to have an actual door. So if we push the add and we search for static, you'll see at the bottom here we have the static mesh component. I'm going to add that in, and I'm going to call this SM underscore door. No, door frame, I think. I'm going to start with the frame. Okay, and for this, now we're not actually showing anything, as you can see, and that's because we have not selected a static mesh. So with the door frame selected in the components panel, I'm going to come over to the details panel, and under the static mesh, I'm going to do a drop down, and I'm going to search for the frame, and you should see there is a SM underscore door frame. I'll select that, and you should have something that looks a little bit like this. Now we need an actual door to go inside our door frame. So I am going to push plus again, search for static again, and we have a static mesh here. So I will add in another static mesh, and I'm going to call this SM underscore door. Okay, and with that selected, we need to apply a static mesh again. So drop down, I'm going to search for door. And you'll see at the top here, we have a SM underscore door. Ta-da. Now, we need to move this into place. So if you drag this, you should see that you have a problem getting it perfectly in place. That's because we are snapping in increments of 10. If you change the snapping increments to 5, you should find that we can place the door exactly in the right place. Okay, so that gives us our main elements. Now I'm going to add in, I think I will add in, I'll do this now, but I'm going to add in an extra add, and I'm going to look for a light. So in this, we have a point light. And so you see that this is adding in a light component to our actor. Now, what I would like to do is I'm going to change some of the settings. The first thing is I don't want this to be a child of the SM door. It's better that it's a child of the frame, because then if the door moves, we don't want the light to move at the same time. So I'm going to drag up my light so it's a bit above it. I'm going to change the attenuation radius, because that's how far this light goes. I'm going to change it to about, I'm going to change it about 200. Okay, maybe I'll move it down. And I'm going to change the light color to be green. So if I drag that down, I'm going to use this to indicate if it is locked. Okay, so now we have our very own door. If I compile, I can now take this door and drag it into the world. Now I can have multiple copies of this door. As again, these are instances of the door. So I've got two doors here as we're working. Okay. So that's the beginning setup. Now we can actually jump. Oh, we got one more element that I'd like to add in, one more component. And that is a box collision. Now, if I push add, and I'll search for box, you'll see that this is a box collision. You'll see that it will create a small box down here. Now I want to move this out, and I want to increase the size of this box. so that it's over a slightly larger area. So that should be enough. Now, we're going to use a box collision. Again, should be child of the door frame. We're going to use this to determine if you are close to the door or not. Okay, so we have all of our components composed. Is anybody seeming to have problems, or are we all okay?
Ed, if you could just quickly go over what components you added again. We had some starter content issues.
Okay, no problem. Okay,
Thanks.
so I have added. Uh, what I'm going to do is I'm going to do a quick run through from scratch. So I will delete these, jump back in. So the first thing I'm adding is a static mesh. And I'm going to rename this to SM underscore door frame. Spell it correctly. Okay, and I have to set the static mesh. So I'm setting that to SM. I'm just going to search for frame. And you'll see that the door frame, SM underscore door frame is there. I'm going to select that. Next up, I'm going to add in another static mesh. And this time I'm going to search for door. And I'm going to rename the component to be SM underscore door. Okay. Well, the next thing I'm going to do is move this so that it's in place. Now, you may need to change the snapping in order to get it to that point. Now, off the door frame, I'm going to add in a couple more components. So first one I'm going to do is add in a point light. And the point light I'm going to drag in front of the door, just so that I can use it as an easy way to color the door, really. And I'm going to change the attenuation radius down to about 200 and the color to green. So we got green for an open door. Now that's okay. It's all fine. Right, next up, I am going to add in a box collision. So I'll search for a box and it will be a box collision. I'll select the box collision. Then I'm going to drag this up to be in place and move this out like that. Is that better?
Yep, that should be good. Thanks for doing that.
Okay, no problem. Okay, so we're going to want to add some code in at this point. Now, at the moment, as you can see, we've got 3 events that exist. We've got begin play, begin actor overlap, and event tick. Now, we're not going to use any of these at this point, so I'm just going to get rid of them. We might come back to some, but what I'm going to do is I'm going to get some new events in here. And the main events I'm going to get are from the box. Because we've added the box collision component, as we can see in the world here, there are a couple of events which are pre-written to function with the box. So if you were to highlight the box, right-hand click, you would see that we have an option of add events. And this has got a lot of different events here. Now we want 2 of these. We want on component begin overlap and on component end overlap. If you select one, it will create an event, right-hand click, and select the other one. So you should have 2 events which look like this. On component begin overlap and on component end overlap. And if I was to put a print string on both of these, I'll just connect them both to the same print string. Actually, no, I'll do the overlap. You don't need to follow along with this bit. I'm just demonstrating how they trigger. So what we would see is as we go into the level, as I overlap with one, you can see that it says overlapped in the top left-hand corner. And when I leave it, it says end overlap spelled incorrect. So we can see when these are triggering. That's why we use these print strings so that we can see, so we can detect something like a trigger. So again, you don't need to do that bit. I just want to demonstrate that this fires when an actor overlaps with the box, and this fires when the actor stops overlapping with the box. Now, this is a little bit interesting because what we're actually going to do is we talked about player controller, and so the player controller is a class which listens for input from either a keyboard and a player and a control pad, or it can be you can have an AI controller which is run by the computer. Now we want to open this door. And this is not the best way of doing this, but it's a good demonstration of we'd like to do this using a key. Now, most of the time you'd write this functionality onto a player, onto a player character, but just for this, we're doing it in a little odd roundabout way so we can demonstrate stuff. There is a way of allowing different actors to listen for inputs. Now, what we're actually doing to do that is we have to piggyback off the back of a player controller. So this is a good example of I want to enable input. And if I was to type in enable input, you'd see there is actually one here. So that would allow me to enable input on this actor. And this, if I type in disable input, would allow me to disable the input on this character. And I want to connect those up. Now, this will compile, but this will not work without the player controller connected up because it doesn't know what input to be listening to. And we want to piggyback off the player controller. So in order to get the player controller, I'm going to right-hand click and type get player controller. We can see that there is a pure function here, the get player controller. This asks me which player, but we've only got one, so 0 will do. I'm just going to connect that up to the player controller in both of these sections. So now our BP door is going to be, will be able to listen for inputs because it's listening off of this player controller. But only it will enable inputs when we enter into the component, enter into the overlap box, and it will disable it when we leave the box. Now, we're not going to see anything at this point, so we need another event. So just down below, if you right-hand click and you type in key Z, this will bring up two different events here. We're actually looking for the second one, which is key Z here. And this is an event which is connected to the keyboard, the keyboard button Z. Now I want to change the button. There's a couple of ways I can do. I can either do a drop down and select any input at this point, or if I click on the select value and then push E, we'll now see that this is connected to the button E. And I would like to do a print string after this so that we can test it out. So if you can make sure you've got that piece of code and that it compiles, we'll be able to jump into the engine to test this out. We'll save, compile again. Now, if I push E whilst I'm standing here, nothing happens. If I walk close to the door and push E, it says hello. That's because the input on that door has been turned on. And I can do the same with this door here. The further I get away, the input is disabled. So it's only when I'm close to it. Are people generally all right with that, or is there problems?
I think we're good to go.
Yeah. Okay. Right. Okay. So let's open the door. Let's write a script. And for opening the door, we are going to use something called a timeline. So what I'm going to do is I'm going to kill this print string, drag down, and I'm going to drag off of pressed. And I am going to search for a flip flop. We can see this here. Now, a flip flop is interesting because what happens with the flip flop is the first time that you access it, it will go down the A line. The second time you access it will go down the B line. So this is, so it will flip flop between the two inputs. Okay, and this is useful because you either want to open a door or close it. So we've got two different functionalities. Now, what I'm going to do is drag off and I'm going to search for timeline. And at the bottom here, you can see there is an option to add a timeline. So I will select the add a timeline. And I'm going to rename this to open, close, door. And I'm going to connect the B to reverse. Okay. Now, timelines are interesting. They are simply, they allow you to key in values over a time period. In order to set up a timeline, if you double click on it, it will open it up like this. Now, first thing is we need to determine the length of the timeline. And 5 is too long because all we want is to open and close a door. I forgot you usually go for 1 second. So I'm going to change the length to 1 second. So this means this entire timeline will run during for 1 second. And if I run it in reverse, it's going to go from 1 second to 0. If I play from play, it's going to go from 0 to 1. Okay, now we need some tracks. And we're only going to need one track. There are a number of different options. We have a float track, a vector track, an event track, and a color track. And what these are is they are different ways of keying in values, so they change over time. Now we're going to use a float track to start with. Now, we haven't discussed what a float is yet. So I will, but a float is, we'll have a look at variables in a second, first time we use them, but it's a number. And it's a number which can have decimal points, floating points. So it's just a singular number. Okay, and as soon as I add it in, and I'm going to rename this to a rotation alpha, I think I'm going to use. It's going to bring up this little chart here. Now, I want to, if you right-hand click, you can move around to move it to a different value. So we're going to look at it from here. Now I want this to be a value that goes from 0 to 1. So I'm going to right hand click on 0 and I'm going to select add key to curve float. And I'm going to come up to 1 and I'm going to right click on 1 and go add key to curve float at the end. And you should hopefully get a line that looks a little bit like this. Now I'm going to correct the values so they're spot on. So it's 1, 1, and the bottom one is 0, 0. And okay, so that's good. But I'd also quite like this to be not so much of a sort of binary stop-start. I want a bit of a curve in or out. So I'm going to grab left-hand click on the outside here and drag across to create a marquee that selects both of these. Then I'm going to right-hand click and change the key interpolate to auto. And you'll see that we get some handles and we get a nice in and out curve. So is anyone having trouble with that? Timelines can be a bit fiddly if you've not used them before. Okay. So that's done. I think that's all fine. I'm going to press X there. And now what you'll see is we now have a new output pin. It's called a rotational alpha. And so that is what I've named the track that we've created in. Now, how this works is anything that we connect to update is going to be run on tick during the time that this timeline is running. So it'll run for 1 second. Now, the output pin at 0 will give us the value 0. At 0.5 will give us the value 0.5, and at 1, so 0.5 of a second through, it will give us 5. And at 1, it will give us the value 1. Now, you don't need to copy this. I'm just going to add a print string on so that I can demonstrate it. So, and I'll change that to black so that it's easier to see. File. So now if I walk up to one of the doors and I push E, you can see that it counts up to 1. And if I push E again, it counts back to 0. But it also gives us all the values in between. That's because every single tick, whatever is attached to the update, is going to be played. Let's demonstrate that again quickly. So, up, down. Now, we're only getting a value between 0 and 1. And that's because we're going to use that as an alpha to lerp between 2 rotations. So what do we want to rotate? Well, we want to rotate the door, not the frame, but the door. So I want to set the rotation, and I want to set the relative rotation. So how would I do that? Now, the first thing is, it's going to want to know what to set the rotation on. So I'm going to need a reference to the door. And I could either do that by dragging it out of these variables, where it's created a variable for each of the components, or I could just left click on the component, drag it in. And as you can see, there's suddenly a blue pin. And this blue pin is a static mesh component object reference. So this is a reference to that door. And now if I drag off of the door with context sensitive, like you can see how much it's limited the options that we have. If I was to type in rotation, I would see all of the options which are available to me for rotation. And I'm going to have a number of different ones, but the relative rotation is the one that I care about because I don't want to set it in world space. So relative rotation. So now you can see here that I have a number of different options. I've got set relative rotation and get relative rotation. And now sets and gets you're going to find all over this. And what a get will do is that will return the value of the relative rotation. What the set is going to do is it is going to like change it to that value. So we want to set in this instance. So we have a set relative rotation. You're not going to be able to find that unless you're grabbing from the context sensitivity of that. We want to connect that to the update. So what this node is doing is it's getting the component and it's setting the rotation. Now we want to set a rotation here. Now I'm going to do that by using something that's called a lerp or a linear interpolate. How are we doing for time? So I'm going to drag off of this new rotation. I'm going to type in lerp. And a lerp is a very useful node that's used all over the engines, but what it's doing is when you grab a lerp, it's going to give us two values, an A and a B pin, and then it's going to give us an alpha. And if the alpha is 0, the value that's returned will be A. If the alpha is 1, the value that's returned is going to be B. Now, if the alpha is 0.5, the value that is returned is going to be halfway between those two values. So this is what allows us to gradually go through the rotation. So I'm going to get the rotation alpha, and I'm going to plug that into the alpha here. So now, on tick, we are updating the rotation, and the rotation is being controlled by the timeline. The only thing I need to do is set these two values. So we know A is closed. So if we look at the viewport, the rotation is 0, 0, 0. So we're fine with that. We don't need to change that. We do now need a rotation for open. So what I'm going to do is I'm going to grab and open the door. So that's where I want it to be open. So I'm going to make it 100. So 100 on the Z axis. So I'm going to make that 100. So what this is going to do is it will move using the alpha and the lerp. It's going to change the rotation to move between these two values. So hopefully you will have this. Okay, I'm going to compile and save and jump back to the first person and test this out. So if I walk up to a door and press E, see the door will open. If I press E again, it will close. So we've animated a door opening and closing. And if I only allow the timeline to get halfway through, it will change the direction because it measures the point that the timeline was in. So it's quite good at setting the rotation. Is everyone able to do that to start with? Are there any questions or people stuck?
I think we're good right now.
Okay, fantastic. In that case, let's look at locking the door. So this is our first case where we're going to be looking at variables. So in the left-hand side here, we now have some variables, and let's create a new. So I'm going to hit the plus button under variables, and I'm going to call this is locked question. Now, what is a variable? If you come from a programming background at all, you probably encountered a variable. But I think the easiest way to understand it is it's some allocated memory where we save something. And when we say save something, it can be a lot of different things. But it's somewhere in memory is allocated to remember, to memorize a something. Now, if you want to know what you can do, as you grab a variable, we have variable types here. Now, the first things that you can remember is a Boolean, and a Boolean is a byte. It is a 0 or a 1. So, and this is red, and you'll see that this is used often in things like branches, but a 0 or 1 is usually used to denote true or false is things. So, for example, we have in this case is locked is perfect to be a Boolean. You don't need to know how locked it is. You don't need to know the value. You just need to know, is it locked or is it not locked? So it is a Boolean value. It cannot exist in a state between locked or unlocked. It can only be one or the other. Next up, we have these green ones. So all these green ones are numeric. And they're primarily, there's a couple of things about how they behave and the amount of memory that's allocated. Now, the main ones you're going to care about is integer and floats. Now, a float we've already encountered, but they are allowed a floating point value. So you could have like 3.1456 or whatever pi is, or you could have 0.2, which, or any value which could have a decimal point or no decimal point. Now, often we will use between 0 and 1 because this is a percentage. So you'll find that we often use that as a simple way up. But they can have decimal points. They take a little bit more memory, which I wouldn't worry about too much. Otherwise, we have integers. Integers are the opposites of floats. They cannot have decimal points. So an integer will count like the amount of people at a party or the amount of bricks in a wall. It does not account for decimal points. It's quicker than a float, and it's less confusing in a lot of instances. Like how many times you want something to go around a loop or something. So an integer is a whole number. We then got a few text ones: name, string, text, and these are all combinations of characters that can. The main one I'm going to mostly use and stuff is string, but I think text is great for localization, which Unreal does fantastically. And name is usually used internal referencing in code. Next up, we have vector rotator and a transform. Now, these are something that's called a struct, and a struct is something we're going to come across quite a few times. It is a combination of other variable types that can be broken down on things. So a vector is a simple struct, is a struct of 3 floats. And this is very often used when you're working with 3D stuff. For example, location is X, Y, and Z as is a vector. Rotator, again, X, Y, Z. And transform is a struct of 3 floats. So this would include, so I'll show with a transform. So I'm going to drag transform in. So you'll see when you drag them in, so you get a choice for a get or a set. Get will read the value in the data, saved data, and set will change the value in the data. So get, this is orange is for transform. If I right-hand click, you can see I can split this struct pin, which will give me the location, rotation, and scale. And I can even go right-hand click and I can split the location, which will give me X, Y, and Z. And also right-hand click and recombine and recombine. But that's what a struct is. And you'll sometimes find that we got massively more complicated structs. For example, a line trace by channel has an output. This blue thing is a hit result struct. If I right-hand click and split, you can see we've got loads of data about location, elements, and stuff like that. So that is the orange one. Now, the final one that we've got, which is of interest, is the blue pin. And there are lots more, but a blue pin is usually a reference to something. So you can see here, this blue pin is a reference to a component within it. And this is a reference to the other actor, the player controller. If you hover over the blue pin, you can see what it is a reference to. And if you look on the other side, you can see what the reference is to on the other side. And these generally have to be the same in order to connect them up. And that is going to be a class in here. So this is a class of a static mesh component. But references are very important. Okay, and we can go into that in more detail, but let's just get through the image. Okay, so I'm going to, the other thing you can do is create a new array by dropping down this. We can have multiple objects. It's like a list, but we don't touch on that. We might touch on it. Okay, so we have our Boolean array. I'm going to hit compile, and you'll see that I can set a default value, and I don't want it to be locked. Now, I'm going to place a branch in here. So I'm going to place a branch before the flip-flop, and I'm going to only connect it to false. And I'm going to drag in locked, drop, and go get is locked. Connect that up to the condition. Okay, so that gives us our is this so if this is an if statement, we're saying, is this locked? Is the variable set for lock? If it's false, then go and open it up. And if it's true, then do nothing. Okay, now I want to be able to set this on different instances to a different. Actually, I'm going to set on construction script. I'll create I'm going to create another event here. So you drop down, if we go custom and and you'll find an add custom event. And I'm going to call this change light color. So you can see I've created my own event here. It's called change light color. Probably should have done this as a function. Before this, I'm going to drag in the point light. And off the point light, I'm going to do change color. No, sorry, set color. Set light color. Oh, yay. Okay, so I'm going to do a little bit of explanation of what I did there. So I dragged in point light, and I dragged off the point light and did set light color. And what this is going to allow me to do is change the color of the light. So if we look under the light, we have the light color here. Now, I then took the pin and I dragged it into the change light color, and it made an input node. And why this is useful is because I can now reference this I can now call this event from multiple places. So actually, no, I don't want to do that. I want to do, actually, I'm going to take that out. If you remove I'm going to delete that. I want to do this in a different way, sorry. So the new light color, I will do a select color. So what I've done now, sorry, is I've dragged off the new light color and I've done select color. And then I'm going to drag in the is locked. And what this does, because I've got to select, is it's going to return a value depending on if it is locked or not. So if it's true, it's going to pick A. So in this case, if it's locked, I'm going to make the color red. So as you can see as I press OK, if it's not locked, I'm going to make the color green. So now, whenever I call this event change light color, it will check to see if it is locked, and it will change the color accordingly.
Hey Ed, we're a couple comments that we're moving a little quickly. Could you maybe go over this custom event a little bit again?
Sure, I will. I'll run this from scratch again. So I'm going to right hand click. I'm going to go add custom event. So we have an add custom event here. We could also do this as a function or even a macro, I think. So I will add a custom event, and that's going to bring that up like that. I'm going to rename this to change color, change light. Okay, now from the change light color, I'm gonna find the point light, because this is what's dictating the color. Drag that in and drop it. So I have a blue reference to my point light. I'm going to drag off, and I will and I'm going to go change. No, I'm just going to look set light color. Now I will connect that up. So the only thing that happens on this event is I change the light color. Now the next thing I want to do is we have this is a struct which is a linear color. We want to change this dependent on if the door is locked or not. So if I drag this out, I'm going to type in a select, and you'll see that there is a, I think, select color. And what this will do is the return value will be dependent on what the input pin value is here. So I'm going to drag in is locked. This time I'm actually just going to place it over the pin, and it's going to give me a green tick because it's going to say, all right, because this is a pin thing, it wants you to get and to be set up. And it'll automatically get it and place it there. So the next thing I want to do is set these two colors. Now, if it is locked, we know it's A, and if it's locked, I want it to show as red. So under the linear color, I'm going to left click, and I'm going to change the red to be 1 and go OK. Then if it isn't locked, I want it to be green. So I'm just going to select the color green. So you should hopefully have something like that. Is that okay?
Yeah, I think we're good now.
Okay.
Thanks.
Right, so I'm going to compile. We want to call this. Now, I'm going to call this on construction script to start with. So on the construction script, I'm going to drag out, and I'm going to change light color. And you'll see that we have the change light color. So that is going to allow us to update the light color based on if the door is locked or not. Okay, so I am going to, now that's great, but we have no way of locking or unlocking the door at this point. So if we come down to the is locked, now you'll see with this selected, we have a number of different settings. Now the one I'm interested in is the instance editable. And what this means, if I select it, you'll see there's a little eye that clicks on. This means that now, if I compile and jump into the level, if I was to select one of the instances of the door, you'll see under the defaults, we have a tick box that says is locked. And if I was to tick that on, now the light would turn red. And so by ticking that, by making it instance editable, it means that you can change the settings manually per instance. So we now have one door that's locked and one door that is open, which is demonstrated by the lights that we can see. Okay. And now I'm jumping back into the door. We can also see that we've got, hopefully you've created a branch here next to the E. So is locked should block the door opening or closing. Now I'm going to save and compile and jump in. And now, if I come up to this door and press E, nothing happens. If I go up to this door and press E, the door will open and close. $10. So please test that. Is anyone pulling up any problems? Okay. Now, we're 10 minutes until the end roughly, but I'm going to push through until we got to the end of these two examples because we'll just take some time out of the lab afterwards. So I don't want to rush these things so that you don't get the full event. Okay, so you do tell me if I'm going too slow or people aren't keeping up. Right. Okay, so we've got our change light functionality, we've got our open door, and we've got our turning on our components, inputs and outputs. So what I would like to do next, I want to be able to control these from another actor. So if you right-hand click, and we'll create a new class. So we'll do a blueprint class, and we'll have this as actor. And we'll call this BP underscore button. So once you've created that, if you double click on the button and open it up, you should have a window that looks like this. Now, again, we're going to need some components. So I'm going to start off with a static mesh. I'm going to call this SM underscore button. Now, for this, the static mesh that I'm going to be looking for, I think if we type in corner, if you type in corner, you'll see there's an SM underscore corner frame. So that's the one that I'm going to use for this button. Now, next to this, I will add in another box collision. We're going to use this in a very similar way. So what I'm going to do is I'm going to scale this up. Move it slightly in. Okay, that's cool. So we've got a box collision and a button. Now, there's no other movable parts with this. So I am going to, we're done with the components. However, with the box, if you right-hand click, we're going to want to add two events in. So again, we've got the component begin overlap and the component end overlap. So if I right-hand click, add event, and component end overlap. So just like we did on the door.
Hey Ed, could we take like 3 minutes to catch up on some thoughts, on some questions on Slack before we continue?
Sure, no problem. Well, I mean,
Or
Yes.
I guess we've got the recording too if you just want to continue through with this.
Oh no, it would take a couple of minutes if you just let you guys. I mean, this is the last bit, so but I want to go slowly just to make sure that everyone has got this. So hopefully everyone has created these two events. So the component begin overlap and the component end overlap. And again, this is off the box collision we've created. Now, I want to use exactly the same code I had on the other one. So I'm going to jump back to the BP door, and I am going to highlight both of these, and I'm going to press Control C. So I've gone back into the BP door. I've selected both the elements that come out of the component begin overlap. And then I'm going to jump back to the BP button, press Control V, and connect these two up. Okay, now I'm going to come down and I'm going to grab the E button as well. I'll just copy that, or you can set it up again. So we need the E button. If you want to set it up from scratch, just search for key. I usually go for Z because it only gives you one entry. If you do E, you're going to have to search until you find it. So Control Z, and then change it in here. So for example, okay, so once we've got E set up, what I'm going to do is I'm going to create something else within the variables. I'm going to do down plus down, and I am going to create a variable of type BP underscore door. And as you can see, when I type in BP door, I can choose an object reference. Now, I'm going to change this object reference to be called door. And I'm going to make this instance editable again. So I can just click on this little I next to it. This is, I could call it door actor, is probably a better take on it. So this is a reference to a door. Now, when I push E, what I want it to do is I want to get, so I'm going to get my reference to my door. But when this is a BP door object. If I drag off of this, I can set is door. What was it called? It set is locked. Now, if I'm setting this, I want to reverse what it was. So in that case, I'm going to get is door. I'm going to get is locked. And I'm going to search for not. Not is equal. I'm going to look for not Boolean. I'm going to plug that into is locked. Okay, so this might be a little bit hard to understand, but what this is doing is we're getting the door actor. So we're getting a reference to the door actor. We're then saying, is it locked? We're saying get the Boolean if it is locked or not. And then we're saying not. So if the Boolean equals 1, the output of not is going to be 0. If it equals 0, the output of not is going to be 1. We're then going to use that to set the same variable. So all this does is reverses the locked variable. So if it is locked, it's going to flip it to isn't locked. If it isn't locked, it's going to flip it to locked. Now there's one more thing I want to do so I can visually see that. I'm going to drag off and I'm going to type change light color. So when I push E, it is going to flip the locked status, flip the Boolean, and then it's going to change the light of the light color appropriately. And you'll note the target for all of these needs to be this reference. Because within this, because it needs to know where it's changing the variable. So I'm going to push compile and save. Then I'm going to jump back into the world. And I am going to drag in a button. And I'm going to rotate it so that we can see both of them. Now, it would just error at the moment because I haven't set the door. But again, I've made this instance editable. So you can see here that in the defaults, when this is selected, I have a drop down, which would allow me to pick any of the actors that fit the class, which is the BP door. Now, I can also, I've got a pipette. But if I select this pipette, you can see that it'll give me a cross unless I am over an actor which fits the class. So if we do it here, you'll see that now the door actor is set within the variables of this instance. Now, if I push play, walk up to the box and push E, you'll see that it changes the color. And if it's locked, I cannot open it. If it's unlocked, I can open it. Okay. Now, there is a this is working. Now, there's a lot more that we can do with this. However, I don't want to sort of drag in. We've got a lab session after this for 1 hour, and there are a lot of sort of bad practices which I've done in this just to sort of demonstrate how this functions. I think tomorrow, I think Martin's going to talk about some of the better ways of interacting between actors. But what I really want you to get away is the concept of classes. So the different classes are going to have different functionality and components which are available to them. And also the concept that these are instances of classes where you can set variables differently on different classes and they will function in different ways. And so we've got the construction script is changing the color to depending on if it's locked or not. The locked is also affecting the functionality of how if we're able to open a door or not open a door. And then we've got a separate actor here, which is capable of controlling and triggering and changing variables on another actor because we have created a reference between the two of them. And this has allowed us from within the button, the door actor that we exposed allows us to control elements on the actor that it's pointing to directly here and even trigger an event we created to change the light. So it's very simple, but it's sort of looking at the concept of classes and the concept of instances within a world and communicating between them. Okay, I'm just going to check down the list, see if there's anything I particularly missed. Yeah, I think that is pretty much everything. Do we have any sort of pressing questions, or should we just jump into the lab, guys?
I think we can just do the lab. People said they're just going to rewatch and pause because some people got stuck behind, I think.
Yeah, and sorry, it's always hard to really want you guys to get this and to stuff like that, but we've got a lab where we can go over stuff in detail.
Oh, there's one question, actually, if we can go over it.
Yeah.
Someone's asking about what the not node does.
Okay, so the not node is so I think this might be easier to if I got a notepad here. Okay, so if we have a Boolean, so a Boolean can either be 0 or 1. I'll just increase the format font. So a Boolean can be either 0 or 1. Now, sorry, struggling here. Now, what a not will do is if I say a not will reverse that. So it is either 0 or 1 if the Boolean, so if locked equals 1, then the not, it is not 0. And because it's binary within a Boolean, not makes sense. You couldn't do it with you couldn't do it with another sort of value. But you'll find that this is part of a whole logic structure for Booleans, because we've got, it might be something better done in a lab, but there are ORs and there are ANDs and there are NORs and XORs, and there are a whole load of different. So if I come onto maths here, you'll see under Booleans, these are all the different sort of values that will convert. So an AND, so we have an AND, it'll have 2 inputs, and only if both of them are true is this going to be true. If one of them is false and the other one is true, this will come up as false. And it's always true or false. So if door is locked and house is on fire, you are in trouble. So if both of them are true, you're in trouble. If the door's open or the house isn't on fire, then you're not in trouble. And so you could have that kind of setup. So if I was to create house on fire, so I'll just Boolean duplicate doors locked. And duplicate in trouble. I think it's one of the easiest ways is because it is so conversationally makes sense that you can start. So in this case, we're saying if the house is on fire and the doors are locked, you're in trouble. If one of them are not true, you're okay. Trouble would be set to false. So that's a sort of and. A not is is a reversal. This is not locked. So is locked is true, not it's unlocked. And there are numerous sort of ones that come from that, but it's Boolean maths, but it's a lot more conversational. It's a lot like if you get in the habit of using variables with good naming conventions, it can be quite readable. So, okay, unless there's any other specific questions, I might finish up there and jump into the lab where we can all talk.